Number 2 wants you to solve the problem. It gives you a formula and it tells you that T is in days, and then it wants you to find the amount present after 12 days. So your equation it gives to you, and you just need to plug in T equals 12. So in your calculator, when you type this in, it should give you 329.287. For number 3, it says that force is varying inversely with the radius r of a curve. So that's why we've used division right here. And then when it varies directly, that means we use multiplication. So the weight of the car and the speed the car is traveling is squared is varying directly, so we make a product out of that. This C right here is just a constant. We always have some sort of constant when we're talking about inverse and direct variation. So that C is a constant needed for that. So this formula is where F is force, W is weight, S is speed, and R is radius. So in the first part of the problem, we need to find our constant C. So it says when the force is 3,000 and the weight of the car is 2,000 pounds and the radius is 500 and the speed is 30 miles per hour, we take all of those numbers, fill them into the formula, and solve for C. So the first thing you would do is you square 30, then multiply that times the 2,000, divide that by 500, and you get 3,600. To solve for C, we divide both sides by 3,600, and that simplifies to 5/6. So the next sentence in the problem wants us to find the force when we're looking at the same car, so the same 2,000-pound car. This time the radius is 800, and the speed is 60 miles per hour, and now we know C is 5/6. Plugging all of that into our formula here. I've separated C out by itself as a product just so we can see what's happening a little bit better. So the first thing we do is we square 60. Then we multiply that result times 2,000, divide that by 800, multiply that by 5 divided by 6, and we get a force of 7,500. The next one, we have to set up a system of equations. We need two different principles split up between two different interest rates. So I've let X be principal number 1, and I've let Y be principal number 2. So we know that together, X plus Y makes a total of $90,000 because the realtor borrowed a $90,000 loan. Then we know, according to the interest, that for principal number 1, we had an interest rate of 5.5%. And then for principal number 2, we had an interest rate of 6%. So that's why the numbers are in front of X and Y for the second equation. We have to change the percent to a decimal. 5.5% is 0.055 in decimal form. 6% is 0.06. So since 5.5 is for the first principal, it's in front of X. Since 6% is for the second principal, 0.06 is in front of Y. And this is how much the interest was together. So from here, it's very easy to use substitution as your method for solving the system. So what I've done is I've taken the first equation, X plus Y equals 90,000, and I've subtracted X from both sides. So now it's solved for Y. What we're going to do is we're going to take what Y is and we're going to plug it in for Y in the other equation. So this looks like 0.055X plus 0.06 times negative X plus 90,000 equals 5,125. So next we need to distribute our 0.06. So 0.06 times negative x makes a negative 0.06x. 0.06 times 90,000 is 5,400. And that's equal to 5,125. So then we have like terms we can combine right here. 0.055 minus 0.06 is a negative 0.005x plus 5,400 equals 5,125. Continue to solve, subtract the 5,400. We have a negative 0.0005x equal to negative 275. I think I got carried away with my zeros right here. I think I have one too many zeros. So now we need to divide by negative 0.005. So x is going to be 55,000. Okay, so this is just one of the two answers that we need. So if x is 55,000 and x plus y is 90,000, I went back and got one of the original equations. I can take x equals 55,000 and plug it in. And solve for y. So if x is 55,000, y is 35,000. So the two amounts you're looking for are $55,000 and $35,000. The last one gives you a function where x is in minutes and y is the cost of a phone call. So if we talk on the phone for 7.5 minutes, all we have to do for the function is plug 7.5 in for x. When we do that, we get 7.125, and since we're talking about money, since we're talking about the cost of a 7.5 minute call, I'm going to round that up to $7.13. So for a 7.5 minute call, it costs $7.13.